Because the equilibrium constant is determined or calculated based on a ratio of products to reactants, the numerical value of the equilibrium constant gives us some information about the relationship of these two concentrations. For example, if K is equal to 1, that means the ratio of products to reactants is equal to one another. And generally, you won't find an equilibrium constant of 1, but you'll find an equilibrium constant maybe close to 1, of 3 or 4 or 5, and that means the concentration of reactants and products are very similar. If the numeric value of K is greater than 1, that indicates that there are more products than reactants. Remember, products are in our numerator, so if K is a large number, that means that the numerator is larger than the denominator, or the concentration of our products is greater than the concentration of our reactants. If K is less than 1, that means that the concentration of our reactants, which are in our denominator, is greater than the concentration of our products, which are in the numerator. So let's go ahead and apply this. Table 9.4 of your textbook summarizes how to interpret the values of K, and let's look at sample problem 9.5. K for the following reaction at 25 degrees is 1 times 10 to the 2. So pause the video and determine at equilibrium, are the products or the reactants greater in concentration? Well, first, before we go over the answer, I just want to go over why the temperature is included. We don't need that to answer the question, but the value of our equilibrium constant does depend on the temperature. If we change the temperature, then our constant will change. So we notice that our equilibrium constant is greater than 1, and so that means the concentration of our products is going to be greater than the concentration of our reactants.